Welcome to this new video. In this video, we shall discuss types of redox reaction. I will give you reactions that can undergo redox reaction. There are so many chemical reactions that are redox in nature, while some are not redox in nature. Let me first of all give you those that are redox in nature, which are types of redox reaction. Types of redox reaction. Let us start with the first one, types of redox reaction. The first type of a redox reaction is thermal decomposition. Thermal decomposition into elements. Thermal decomposition into elements. An example is this: when you have silver oxide decomposed to give you Ag plus oxygen gas. If you balance the equation, put 2 here, put 4 here, the equation is balanced. When you have this thermal decomposition into elements, it's an example of a redox reaction. Let us see if it is truly an example of redox reaction. If it is truly an example of redox reaction. I told you a redox reaction is a reaction where you have both reduction and oxidation reaction occurring at the same time. Let us see if that is the case in this. Look at this. What is the oxidation number of silver in silver oxide? When you have this 2 minus plus, this one come here, this one come here, you have Ag2O. The owner of these two is what? Oxygen, which is minus 2. While the owner of this one is what? Silver, which is plus 1. If not, you can calculate it. Ag2O. Silver is unknown. The oxidation number of silver is unknown. That means X. How many silver do we have? 2. 2X plus oxygen is minus 2 equal to 0. You have 2X minus 2 equal to 0. 2x equal to plus 2. S equal to 1 plus 2 over 2. S equal to 1 plus 1. That means oxidation number of silver is plus 1. While oxidation number of oxygen, is minus 2. It's one of these two, which is what? Minus 2. When you have this, is what? Minus 2. The owner of these two is what? Oxygen, which is minus 2. Then let's come to the product side. At the product side, what happened? The oxidation number of silver is what? 0, because it is an atom, it is neutral, it is standing alone. I told you when you see an element standing alone in the chemical reaction, the oxidation number is what? 0. Oxygen, what is the oxidation number? Standing alone, it is neutral, 0. Then from here, what happened? Silver from plus 1 to what? 0. That means it has decreased in oxidation number. It has decreased in oxidation number. And when there is decrease in oxidation number, what reaction is that? Reduction reaction. That means when there is decrease in oxidation number, that is reduction reaction. Then minus 2 to what? 0. When there is increase in oxidation number, minus 2 to 0, oxygen has increased in oxidation number from minus 2 to what? 0. Therefore, from oxygen to this oxygen is oxidation reaction. Oxidation reaction. Why? Increase in oxidation number. That means silver here is what? Oxidizing agent. Oxygen here is what? Reducing agent. Silver in this compound is acting as what? As oxidizing agent. Oxygen in this compound is acting as what? Reducing agent. Take note of that. This is what an example of redox reaction. That thermal decomposition into element. Another this. Let me give you this one. When you have H2O decomposed into H2 plus O2. Look at this. Thermal decomposition into element. What is oxidation number of hydrogen? Plus 1. If you calculate it, H2O. Hydrogen, the oxidation number is unknown. That is X. How many hydrogen do we have? 2. That is 2x plus oxidation number of oxygen minus 2 equal to 0. We have 2x minus 2 equal to 0. 2s equal to 1 plus 2. S equal to 1 plus 2 over 2. S equal to 1 plus 1. Oxidation number of hydrogen is plus 1. Oxidation number of oxygen is what? Minus 2. Then here, hydrogen is standing alone. Oxidation number is what? 0. Oxygen standing alone. Oxidation number is what? 0. Then look at hydrogen from plus 1 to 0. It has reduced in oxidation number. Therefore, from here to here, what kind of reaction? That is reduction reaction. Reduction reaction. Then from this oxygen to this oxygen, what kind of reaction? Oxidation reaction. Take note of that. You can write the two examples. That is thermal decomposition into elements is an example of what? Redox reaction. Let us go to another type of redox reaction. You can pause the video and write it down. That thermal decomposition into elements is an example of redox reaction. You can pause the video and write it down. Let us go to another type of redox reaction. Another type of redox reaction. Let's go to displacement reaction. Displacement reaction. Displacement reaction. Number 2. Displacement reaction. Or single replacement. Or you can call it single replacement. Displacement reaction. Displacement reaction is also an example of a redox reaction. Displacement reaction is also an example of redox reaction. Let me give you an example on this. Let me illustrate this with a chemical reaction. When you have zinc plus HCl to have zinc chloride plus hydrogen gas. Look at this. Balance equation put you here. The equation is balanced. When you have zinc plus HCl to give you zinc chloride and hydrogen gas, this is what? Displacement reaction. Can you see? Zinc has displaced hydrogen. That means it has replaced. That's why you can call it single replacement. Zinc has replaced hydrogen. From here, it has replaced hydrogen. That means hydrogen is being what? Displaced. That's why it is called displacement reaction or replacement reaction. You replace hydrogen with what? Zinc. You understand? Replacement reaction, single replacement reaction or displacement reaction. It's an example of redox reaction. Let us verify. What is oxidation number of zinc here? 0. What is oxidation number of chlorine? Or what's oxidation number of hydrogen? Chlorine -1. What's oxidation number of hydrogen? +1. Oxidation number of hydrogen is +1. Oxidation number of chlorine is -1. What is oxidation number of zinc in this place? Is one of these two, where you have zinc 2 plus, chloride minus, chloride ion. Wow, you have zinc, this one. That means these two belongs to what? Zinc. That means the oxidation number of zinc is what? +2. While oxidation number of hydrogen is what? 0, standing alone. 0. That means I don't need this. The oxidation number of chlorine still remains -1, -1, -1, -1. That means spectator agent. The oxidation number of chlorine is -1 here. Here is still what? -1. That means chlorine is a spectator what? Agent. That means the oxidation number does not change. Spectator agent. But let's move. Look at this. Zinc from 0 to what? +2. Hydrogen from +1 to what? 0. That means zinc has increased from 0 to what? +2. Therefore, this one is what? The reducing agent. Hydrogen from +1 to what? 0. It has decreased. Oxidizing what? Agent. From here to here, what kind of reaction? When there's increase in oxidation number, that is what? Oxidation reaction. Oxidation reaction. And reducing agent undergoes oxidation reaction. Then from this hydrogen to this hydrogen, what kind of reaction? Reduction reaction. Reduction reaction. Take note of that. That means displacement reaction. Take note. Is an example of or is a type of redox reaction. I've given you two now. The first one is for thermal decomposition into element. The second one is for displacement reaction or single replacement reaction. Or let me give another one here where you are in a case when you have this. When you have this, you have zinc plus CuSO4 to give plus Cu. In this case, let us look at it. The oxidation number, this one is also what? Displacement reaction or single replacement reaction. Zinc has replaced copper. Zinc has replaced what? Copper. The oxidation number of zinc here is what? 0. Oxidation number of copper is plus 2. Is plus 2. That's why copper 2 tetraisosulfate 6. Copper 2 tetraisosulfate 6. That is the oxidation number of copper is plus 2. Then cancel each other, you have CuSO4. Copper 2 tetraisosulfate 6. The oxidation number of copper is what? Plus 2. Yeah, the oxidation number of zinc is what? Plus 2. While the oxidation number of copper here is what? 0. Let us look at this. Zinc from 0 to plus 2 has increased. That means reducing agent. Copper from plus 2 to what? 0 has reduced, oxidizing what? Agent. From here to here is what? Oxidation reaction. Oxidation reaction. Then from copper to this copper is what? Reduction reaction. Reduction reaction. Let's move. Let's go to the third type of what? Redox reaction. Another example of redox reaction, another chemical reaction that is redox. Let's move. Combination reaction. Combination reaction. That is synthesis of what? Two elements. Combination reaction. Combination reaction. Combination reaction. Number 3 type, combination reaction. Combination reaction. That means synthesis. That is combination reaction. Combination of two elements. For example, when you have magnesium plus fluorine gas to give you magnesium fluoride. When you have this, magnesium plus fluorine gas to give you magnesium fluoride. Combination reaction is an example of redox. It's an example of redox. What is the oxidation number of magnesium here? 0. What is oxidation number of fluorine? The oxidation number of fluorine is also what? 0. The oxidation number of fluorine is also 0. Why? I've told you that when you see an atom in a chemical reaction, that means it is neutral. When an element is standing alone in a chemical reaction, that means it is what? Neutral. The oxidation number will be 0. Magnesium here. The oxidation number of magnesium, that means magnesium 2 plus fluorine minus. That means these two. That means magnesium 1, fluorine 2. These two belongs to what? Magnesium. Take note of that. Take note of that. That means oxidation number of magnesium is what? Plus 2. Fluorine minus 1. What happened? Magnesium from 0 to plus 2, it has increased, reducing agent. Fluorine from 0 to minus 1, it has reduced, oxidizing agent. That means from here to here, what kind of reaction? Oxidation reaction. Oxidation reaction. Then from fluorine to this fluorine, what kind of reaction? Reduction reaction. Reduction reaction. Take note of that. And I told you reducing agent undergoes oxidation reaction. Oxidizing agent undergoes what? reduction reaction. Reducing agent undergoes oxidation reaction. Oxidizing agent undergoes what? Reduction reaction. Synthesis of two elements, that is combination reaction, is an example of what? Redox reaction. I can give another one where you have hydrogen gas plus oxygen gas to give you H2O. That's another one. The oxidation number of hydrogen 0, oxygen 0. Hydrogen here is +1, oxygen is -2. Oxygen from 0 to -2, it has reduced. Now it's oxidizing agent. Hydrogen from 0 to +1, it has increased, reducing agent. It has increased in oxidation number, reducing agent. From here to here is what? Oxidation reaction. Then from here to here is what? Reduction reaction. From this oxygen to this oxygen, reduction reaction. Take note of that. Let us move to another type. Another types of redox reaction, which is disproportionation reaction. Disproportionation reaction. Disproportionation reaction. Disproportionation reaction. Disproportionation reaction. Number 4, disproportionation reaction is an example of redox reaction where you have I2 plus KOH to give you Ki plus KOH plus H2O plus H2O. Disproportionation reaction. Disproportionation reaction. Disproportionation reaction. Let's look at this. Let's look at this. Let's look at this. Let's look at this. I2 plus KOH to give you KOI. I'm sorry. KOI. Disproportionation reaction. The equation is balanced. Iodine 2, potassium 2. You can balance the equation. Okay, let's look at this. You can balance the equation. Let's look at this. Let's look at this. Let's look at this. What is the oxidation number of iodine? It is standing alone, 0. What is oxidation number of iodine in this one? -1. That means this iodine will be acting as reducing agent and what? Oxidizing agent. This iodine will be acting as reducing agent and what? As an oxidizing agent. That is what they mean by disproportionation reaction. You can balance the equation if the equation is not balanced. But what I want to bring out is that when you have a substance acting as reducing agent and oxidizing agent in a chemical reaction, that reaction is what? Disproportionation reaction. And disproportionation reaction is an example of what? Redox reaction. Look at this. The oxidation number of iodine is 0. The oxidation number of iodine is -1. Let us look at the oxidation number of iodine in KOI rather. In KOI, potassium is 1 plus oxygen is -2 plus iodine is X, everything equal to 0. 1 plus times -2 plus X equal to what? 0. This one give you 1 minus 2 minus 1 plus X equal to 0. Therefore, X is what? +1. In this case, the oxidation number of iodine is what? +1. Please look at this. Here, the oxidation number of iodine is -1. Oxidation number of iodine is +1. And the reactant, iodine is 0. That means this iodine is acting as reducing agent and is acting as an oxidizing agent. In this case, this is disproportionation reaction. It is an example of what? Redox reaction. Then let us look at it. Iodine from 0 to what? minus 1. That means this iodine is a what? Is acting as an oxidizing agent in this case from 0 to minus 1. From this iodine to this iodine. What kind of reaction? Reduction reaction. Reduction what? Reaction. Then from the same iodine to this iodine, what kind of reaction? Oxidation reaction. Why? Because it has increased from 0 to plus 1. And when you increase in oxidation number, that is, you will undergo oxidation reaction. That means this iodine is acting as oxidizing agent and reducing agent. This iodine is acting as what? Oxidizing agent. Is acting as an oxidizing agent and what? Reducing agent. This is disproportionation reaction. When you have a reactant acting as an oxidizing agent and what? As a reducing agent. The oxidation number of iodine at the reactant is 0. At this place, it is minus 1. At the reactant is 0. At this place, it is what? Plus 1. That means from this one to this one is what? Reduction reaction. From this one to this one is what? Oxidation reaction. That means iodine vapor is acting. This iodine vapor act as a reducing agent and oxidizing agent. That is what? Disproportionation reaction. Disproportionation reaction. Let me give you another one, or let us go to the next one. Disproportionation reaction. Disproportionation reaction. Disproportionation reaction. Disproportionation reaction. Number 5. Disproportionation reaction. Where you have H2S plus SO2 to give S2 plus H2O. When you have H2S plus SO2 to give S2 plus H2O. Balance equation, let me balance this one for you. 4 here, 2 here. This one is 3, let me put 3, let me put 4. 4, 8, 8. 4, 6, 6. 4, 4. Balance, 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 balance. Then this is disproportionation reaction. That means you have 2 elements in a compound which they both act as reducing and oxidizing agent. We have sulfur here. Sulfur here will be acting as what? A particular agent. The sulfur in this one will be acting as a what? Particular agent based on the what? The sulfur at the what? Product. Let us look at this. What is oxidation number of sulfur in H2S? Minus 2. Minus 2. Please let me write this one. Disproportionation reaction. Disproportionation reaction. That means the oxidation number of sulfur here is minus 2. The oxidation number of sulfur here, if you calculate it, SO2. Sulfur is X plus oxygen minus 2. How many oxygen times 2 equal to 0? S minus 4 equal to 0. S equal to what? Plus 4. That means sulfur 4 is 4 here. The oxidation number of sulfur standing alone, 0. Then let's look at this. Sulfur increase from minus 2 to 0. Increase from minus 2 to 0 in oxidation number. Therefore, sulfur in this one is reducing agent. That means H2S is a reducing agent. Reducing agent. Then look at the sulfur here, plus 4. It has reduced to what? 0. From plus 4 to what? 0. Here, this is what? Oxidizing agent. Here, sulfur is what? Oxidizing agent. Then from this point to this point, from H2S to sulfur, that is what? Increase minus 2 to 0. That is oxidation reaction. Oxidation reaction. Then from this sulfur plus 4 to 0 to this one, or let me draw it up. Let me put it up. From here to here is what? Reduction reaction. Reduction reaction. This is what they call disproportionation reaction. We have two elements at the reactant in a compound which act as reducing and oxidizing agent, which is determined by what? The one at the product. This is disproportionation reaction. It is an example of a redox reaction. Then let us look at reactions that are not redox in nature. Reactions that are not redox. Number one, reactions that are not redox. Neutralization reaction is not redox. Neutralization reaction. Neutralization reaction is not redox. This one is not what? A redox reaction. If they are to, which of the following is not a redox reaction? And you have neutralization in there, it is the answer. What is neutralization reaction? Reaction between acid and base to form salt and water. That means when hydrogen ion react with hydroxide ion to form water. Neutralization reaction. Reaction between acid and base to form salt and water. When hydrogen ion and hydroxide ion combine. Neutralization reaction. It is not redox. Not redox reaction. Another reaction that is not redox. Double decomposition reaction. Double decomposition reaction. Or it is called double replacement. It is not redox. Double replacement is not redox. What do they mean by that? When you have sodium chloride plus what? AgNO3 to give you sodium triazonitrate 5 plus what? AgCl. This one is not redox. Double decomposition reaction is not redox reaction. Double decomposition reaction is not redox reaction. Neutralization reaction is not redox. Let me give you an example of neutralization reaction. Let me write it on the board. Hope you've written this. Pause the video and write this. Okay. Example of a redox reaction. Example of neutralization reaction. When you have H2SO4 plus sodium hydroxide. When you have sodium tetraoxide sulfate 6 plus H2O. It's not redox. You can balance the equation. This is not redox reaction. It's not a redox reaction. That is reaction between acid and what? Base. It's not redox. You can balance the equation. That means double decomposition is not a redox reaction. Neutralization reaction is not a redox reaction. Take note. Those are not redox. Another example that is not redox reaction. Some decomposition reaction are not redox reaction. Some decomposition reaction are not redox. Some decomposition reaction are not redox. For example, when you have calcium triazocarbonate 4 to calcium oxide plus CO2, this is not a redox reaction. This is not a redox reaction because there is no change in the oxidation state. Calcium is plus 2, carbon is plus 4, oxygen is minus 2, calcium is plus 2, oxygen is minus 2, carbon is plus 4, oxygen is minus 2. There's no change. Likewise, those one I gave to you, neutralization reaction and double decomposition reaction. There's no change. Look at this one. For the double decomposition reaction, where you have this one. Look at it. Plus AgCl. Plus AgNO3. You have NaNO3 plus AgCl. Sodium is plus 1, chlorine minus 1, silver plus 1, nitrogen plus 5, oxygen minus 2. Sodium plus 1 plus 5, oxygen minus 2 plus 1 minus 1. There's no change. Since there's no change in their oxidation number, it's not redox. This decomposition reaction is not redox. Likewise, this when you have calcium hydrogen triisocarbonate 4. This one too is not a redox reaction. That is where you have calcium triisocarbonate 4 plus H2O plus CO2. This reaction is not a redox reaction. Take note. Some decomposition are not redox reaction, especially the one that is not thermal decomposition into element. Thermal decomposition into element is redox, but those ones that are not thermal decomposition into element are not redox reaction. Please take note of that. Please let us solve some questions before we move. Let's solve some questions before we move. Let's solve some questions before we move. From UTME past question, from Jupe past question, let us solve some questions. Look at it. Where you have I2 plus H2O3 2 minus to give you I minus plus SO4 7 2 minus. Balance question, put 2 here, put 2 here. Let us look at this. Let's say, option A, minus 2 to minus 4. Option B, plus 2 to plus 3. Option C, minus 4 to minus 2. Option D, plus 3 to plus 2. Plus 3 to plus 2. What is the change? This is the question. What is the change in the oxidation number of sulfur? What is the change in the oxidation number of sulfur? The change in oxidation number of sulfur. Sulfur is here, sulfur is here. What is the change in the oxidation number of sulfur? Let us look at this. You have S2O3 2 minus. Let us look for oxidation number of sulfur. It's unknown, S. How many sulfur do we have? 2. S times 2. 2S plus oxygen minus 2. How many oxygen? Times 3. Equal to, this one is polyatomic ion, equal to the charge, minus 2. 2S minus 6 equal to minus 2. 2x equal to minus 2 plus 6. 2x equal to what? Plus 4. S equal to what? Plus 4 over 2. S equal to what? Plus 2. Sulfur in this place is plus 2. What is sulfur here? Let us calculate it. Sulfur, unknown, x, that is s times 4, 4x, plus oxygen, minus 2, times 7, everything equal to minus 2. You have 4x minus 14 equal to minus 2. 4x equal to minus 2 plus 14. 4x equal to what? Plus 12. Therefore, x equal to plus 12 over 4. S equal to plus 3. That means here is what? Plus 3. Change in oxidation number of sulfur from plus 2 to plus 3. Option what? B. That is Jupe question. Jupe question 2021. Jupe question 2021. Let's look at another question. 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 I'm sorry, you can pause the video and because of time, let's look at another question. Let's look at another question. Question 2. Question 2. Where we have Cr2O7 2 minus plus Fe2 plus to give you Cr3 plus Fe3 plus Fe3 plus Fe3 plus. If they ask you to identify the oxidizing agent, what will you do? if they ask you to identify oxidizing agent, identify the oxidizing agent. Identify the oxidizing agent. That means oxidize. Identify the oxidizing agent. That means the one that reduces in oxidation number. Let's look at that. Let's look at the question. Let's look at the question. Identify. Look at this. Iron from +2 to +3. Let me ask you option A. Let me give you the option. Cr2O7 2 minus. Option B. Fe2 plus. C. Fe3 plus. D. Cr3 plus. Identify the oxidizing agent. Identify the oxidizing agent. Take note, oxidizing agent and reducing agent, they can never be at the work product side. Then these two can never be the answer. Oxidizing agent and reducing agent can never be at the product side. These two can never be the word answer. Therefore, let's look at this. Iron 2 to iron 3, that one has increased. Therefore, that one is reducing agent. It has increased. Reducing agent increases in oxidation number. Then look at this. Cr2O7 2 minus. What was the oxidation number of chromium? Let us look at that. We don't know. X. How many chromium do we have? 2. That is 2x plus oxygen minus 2 times 7. Everything equal to the charge. 2s minus 14 equal to minus 2. 2s equal to minus 2 plus 14. 2s equal to what? Plus 12. S equal to what? Plus 6. Chromium here is plus 6. Chromium here is plus 3. That means chromium has decreased. It has decreased from plus 6 to what? Plus 3. It has decreased. Therefore, this one is oxidizing agent. That means the oxidizing agent is A. A is oxidizing agent. Please take note. Don't forget to subscribe to our YouTube channel. Please comment. Please like, share. If you need any physical class, you can call one of the 2 numbers on the board. I remain myself, German.